In this video, we're learning how to solve one-step inequalities, and if you look at the top of our screen, you'll see this note that says, solve inequalities the same way you solve equations, but remember to flip the inequality sign when you multiply or divide both sides of the inequality by a negative number. So for these first four examples, we're just looking at addition and subtraction one-step inequalities, so we don't have to deal with this remember part. We'll talk about that in examples 5 through 8. So for examples 1 through 4, we're just going to solve these inequalities the same way we would solve an equation. So let's jump into number 1. So for number 1, we have x plus 5 is less than 7. So when we're solving an equation, we're trying to get the variable by itself. So that's our goal when we're solving an inequality. And to get rid of a positive 5 or a plus 5 on the left side of the equation, we have to perform the inverse or opposite operation. So the inverse of addition is subtraction. So we're going to subtract 5 from the left side of our inequality. And anything we do to one side of our inequality, we have to do to the other side, just like equations. So we're going to subtract 5 from the right side. On the left side, we're left with x, and we have a less than sign instead of an equal sign. And on the right side, 7 minus 5 is going to give us 2. So we get the answer of x is less than 2, which means that x can be any value that is less than 2. So x could be 1, x could be 0, x could be negative 3, x could be negative 4.5. Anything less than 2 would satisfy this inequality. And now we're just going to graph our answer on a number line. And if you guys haven't already done so, I suggest watching our video on how to graph inequalities on a number line. So I'm just going to put a couple points. So I'm going to put 2, and then I'll put 3, and I will put 1. And we want to show that x is less than 2. So because x cannot equal 2, we're going to put an open circle at 2. And x is everything less than 2, so we're going to go to the left. So we're going to shade our number line like this. So this represents x is less than 2. So now let's take a look at example 2, which is a minus 3 is greater than or equal to 12. So again, our goal is to get a by itself. So we have to perform inverse operations to get the a by itself. So we are subtracting 3 from a, so to get rid of it, we're going to do the inverse, which is addition. So we're going to add 3, and we have to do the same thing to both sides of our inequality. So we're going to add 3 to both sides. On the left side, we're left with a, and we have a greater than or equal to sign. And on the right side, 12 plus 3 is 15. So we get that a is greater than or equal to 15, which means that a can equal 15 or anything above 15. And now we're just going to graph this on a number line. So I'm going to put 15, 16, and 14. And this time a can equal 15. So I'm going to put a closed circle at 15, so that means our variable can equal that number. And it is greater than or equal to, so we're going to shade it to the right because it can be bigger than 15. So this is the number line that represents a is greater than or equal to 15. Looking at example 3, we have k plus 20 is greater than 15. So to get rid of a plus 20, we have to do the inverse, which is subtraction. So we're going to subtract 20 from both sides of our inequality. On the left side, we're left with k. So we have k is greater than, and on the right side, 15 minus 20 is going to give us a negative 5. So we get that k can be anything greater than negative 5. We're going to plot this on a number line. So I'll start with negative 5, and I just normally go 1 below, so negative 6 and 1 above. And k cannot equal negative 5, so I'm going to start by putting an open circle at negative 5. And k can be anything above it, so I want to shade to the right. So this is the graph that represents k is greater than negative 5. Taking a look at example 4, we have m minus 8 is less than or equal to negative 17. So to get rid of a minus 8, we have to do the inverse, which is addition. So we're going to add 8 to both sides of our inequality. On the left side, we're left with m is less than or equal to, and on the right side, negative 17 plus 8 is going to give us a negative 9. So we get that m is less than or equal to negative 9, which means m can equal negative 9 or anything below it, so negative 10, negative 11, negative 2,000. And it could be decimals, it could be negative 10.5. It just can be any number less than or equal to negative 9. And we're going to put this on a number line. So we'll start with negative 9. We'll go one below. Negative 10, one above, negative 8. Because m can equal negative 9, we want to put a closed circle. And then we're going to shade everything to the left. So that is how you graph m is less than or equal to negative 9. So now we're going to work through some examples that involve multiplication and division. So these examples deal with multiplication and division. So the only difference when you're solving inequalities is that if you multiply or divide both sides of your inequality by a negative number, you need to flip the inequality sign. So I'll show you guys what I mean in example 6. But let's start with example 5, which is just a pretty straightforward one, and we don't have any negatives. So example 5 is 3x is greater than or equal to 15. So we're going to solve this the same way as we solve an equation. So 3 is being multiplied by x, so to get rid of it, we have to perform the inverse or opposite operation, which is division. Anything we do to one side, we need to do to the other side. So we need to divide both sides of our inequality by 3. On the left side, 3 divided by 3 is 1, so we're left with a 1x, which is just x. So if x is greater than or equal to, and on the right side, 15 divided by 3 is 5. So we get that x is greater than or equal to 5. And now we're just going to graph this on a number line. So I'll put 5, 4, and 6. Because x can equal 5, we're going to start by putting a shaded circle or a closed-in circle at 5. And x can be anything above 5, so we're going to go shade to the right. So now if we take a look at example 6, we have b divided by negative 4 is less than or equal to 8. So this is where this extra remember note is going to come into play. So what we want to do is get rid of this negative 4, and b is being divided by negative 4. So to get rid of it, we have to do the inverse, which is multiplying. So we have to multiply both sides of our equation by negative 4. Now, when we multiply or divide both sides of our inequality by negative, we have to flip this inequality sign. So instead of less than or equal to, we're going to flip it to be greater than or equal to. The rest of our problem is the same. So on the left side, negative 4 divided by negative 4 is 1. So we're left with 1b, which is just b. On the right side, 8 times negative 4 is negative 32. So we get that b is greater than or equal to negative 32. So the only difference there than from solving an equation is that we had to flip that inequality sign because we multiplied both sides by a negative number. And now I'm just going to graph this quickly. So I'll have negative 32, negative 33, and negative 31. b can equal negative 32. So I'll put a shaded circle on negative 32, and it can be anything greater than or equal, so I'm going to shade to the right. So that's how we shade that answer. And now if we look at number 7, we have a negative 7k is less than 56. So we need to get rid of this negative 7 that's being multiplied by k. So we need to use division because that's the inverse of multiplication. So we're going to divide both sides by negative 7. When we divide both sides of an inequality by a negative or multiply both sides by a negative, we need to flip the inequality sign. And now everything else is going to be the same as how we normally solve an equation. So negative 7 divided by negative 7 on the left is just 1. So we're left with 1k, which is just k. On the right, 56 divided by negative 7 is going to give us negative 8. So I get that k is greater than negative 8. And now I'm just going to plot this on a number line. So I'll plot negative 8, negative 9, and negative 7. K cannot equal negative 8, so I'm going to put an open circle at negative 8, and it can be greater than, so we're going to shade to the right. So that's how we shade k is greater than negative 8. If we take a look at example 8, we have a divided by 6 is greater than negative 2. So because a is being divided by 6, to get rid of it, we need to multiply both sides of our equation by 6, both sides of our inequality by 6. On the left side, 6 divided by 6 is 1, so we're just left with a. And we have greater than, and on the right side, negative 2 times 6 is negative 12. So we get that a is greater than negative 12. And some students get a little confused here because we have a negative on one side of our inequality and then we're multiplying by a number and they flip the sign. But remember, we only flip the inequality sign if we're actually multiplying or dividing both sides by a negative number. Since we multiplied both sides by a positive 6, we keep the inequality sign as it is. So last step, I'm just going to graph this. Negative 12, negative 13, negative 11. A is greater than, it can't equal negative 12, so we put an open circle, and greater than we're going to shade to the right. We're going to go through 4 more examples, just mixed examples of addition, subtraction, multiplication, and division, just to make sure that we've got this down. So for these last 4 examples, I encourage you guys to pause the video and try them on your own, and then you can watch me work through them to make sure you solve them correctly. So if we take a look at example 9, it is y plus 6 is less than or equal to 11. So 6 is being added to y, so to get rid of it, we want to do the inverse, which is subtraction. So we're going to subtract 6 from both sides of our inequality. On the left side, the plus 6 and minus 6 cancel out to 0, so we're left with y. So we have y is less than or equal to 11 minus 6 is 5. So we get y is less than or equal to 5. And now we're just going to plot that on a number line. So we'll put 5, 4, and 6. Because y can equal 5, we're going to put a closed circle at 5. And y can be anything less than or equal to 5, so we're going to shade it to the left. So that's how we plot y is less than or equal to 5. Moving on to example 10, we have c minus 4 is less than negative 7. Because c is being subtracted by 4, to get rid of this minus 4, we have to do the inverse, which is addition. So we're going to add 4 to both sides of our inequality. On the left side, we're left with c, so we have c is less than. And on the right side, negative 7 plus 4 is negative 3. So we get c is less than negative 3. And now we're going to plot this on a number line. So we'll put our negative 3, we'll put negative 4, and negative 2. C cannot equal negative 3, so we're going to have an open circle, and it can be anything less than, so we're going to shade to the left. So that's how we graph c is less than negative 3. Moving on to example 11, we have negative 12x is greater than or equal to negative 60. To get rid of this negative 12 that's being multiplied, we have to do the inverse, which is division. So we're going to divide both sides of our inequality by negative 12. Because we divided by a negative number, we need to flip our inequality sign, so I'll do that first. And now on the left side, negative 12 divided by negative 12 is 1, so we're left with 1x, or x. And on the right side, negative 60 divided by negative 12 is positive 5. So we get x is less than or equal to 5. And we don't want to forget to just graph it quickly. So we're going to put a 5, a 4, and a 6. X can equal 5, so we're going to put a closed circle at 5. And we are going to shade to the left because x can be less than or equal to 5. And now we're going to move on to the last one, which is number 12, which is n over 5, or n divided by 5, is greater than negative 4. Because n is being divided by 5, we want to perform the inverse operation, which is multiplication. So we want to multiply both sides of our equation by 5. On the left side, 5 divided by 5 is 1, so we're left with 1n, or n. So if n is greater than. And on the right side, negative 4 times 5 is negative 20. So we get n is greater than negative 20. And finally, we're just going to plot this last one on a number line. So we'll do negative 20, negative 21, and negative 19. N cannot equal negative 20, so we have an open circle. It can be greater than negative 20, so we're going to shade our number line to the right. So that's how we graph n is greater than negative 20. So hopefully this video helped you guys learn how to solve one-step inequalities. You just have to remember to solve them the same way as you solve equations, except anytime you multiply or divide both sides of your inequality by a negative number, you need to flip the inequality sign.